So hello everyone, so my name is Louis J.E. Samole. So my report is all about design of spillways. So first, what is spillways? So passage for surplus water over or around a dam when the reservoir itself is full. So spillways are particularly important safety features for earth dams, protecting the dam and its foundation from erosion. They may lead over the dam or a portion or of it or along a channel around a dam or a conduit through it. So, purpose. So, first is design standard, present technical requirements and processes to enable design professionals to prepare design documents and reports necessary to manage, develop, and protect water and related sources in an environmentally and economically. So, next is the compliance with the design standards assist in the development and improvement of reclamation facilities in a way that protects the public health, safety, and welfare, recognizes needs all stakeholders and achieves lasting value and functionally necessary for reclamation facilities. Responsible designers accomplish this goal through compliance with these design standards and all other applicable technical codes, as well as incorporation of the stakeholders' vision and values that are then reflected in the constructed facilities. So there are three classifications of spillways typically employed by reclamation, which are based on frequency of use. They are explained in more detail in the following section. So first of all, reclamation is based on my research. So there sila ang American firm or American government na naga-encounter or naga-provide aning mga spillways dito sa Amerika. So first is the service spillway. So a service spillway provides continuous or frequent regulated or staged or unregulated releases from a reservoir without significant damage to the dam, like or upward-to-rent structures due to releases up to and including the maximum design discharge. Service spillways are typically very robust, erosion-resistant structures consisting of mostly cast-in-place reinforced concrete and riprap channel protection. Next is the auxiliary spillway. Is infrequently used and may be secondary spillway. During operation, there could be some degree of structural damage or erosion to the auxiliary spillway due to releases up to and including the maximum design discharge. Auxiliary spillways may be less robust, erosion-resistant structures consisting of some cast-in-place, reinforced concrete, riprap channel protection, and or unarmored excavated channels. So next is the emergency spillways. An emergency spillway is designed to provide additional protection against overtopping of a dam and or dike and intended for us under unusual or extreme conditions such as misoperation or malfunction of the service spillway or outlet works during very large remote floods. So this is the some examples of the spillway. So first is the gate spillway. So the gate spillway is mura siya og katong first nga spillway na service spillway, gated siya so makakontrol ka. Next is the morning glory spillway. So morning glory spillway, so mura siya og kanang free fall na water na naay tubig pag magpuno ang dam. Ang water sa dam is mo direct din siya paubos, masuyop niya so dili na magka cause of flood. Next is the gated spillway. So and the step spillway. So next, so this is the example of the emergency spillway, like the grade control steel spillway with riprap. So mga emergency spillway meaning murag nag-extend or murag na siya isa pa ka building structure o isa ka pa ka spillway nga naga-protect in case of emergency na dili na makaya sa isa ka spillway is maprotektahan gyapon ang isa tulong sa isa. Next is the gated service spillway. So that's it, the gated service spillway, the gated emergency spillway, and the gate controlled spillway with riprap armament. So napansin ninyo is reinforced concrete tanan ang gamit sa atong mga spillway because ang concrete is more on strength kaysa other materials para mo musangga og tubig. So this is the design standard. So first is the exclusive flood control pool, joint use capacity, active conservation capacity, inactive capacity, dead capacity, live capacity, total capacity, crest of dam, maximum water surface, top of exclusive flood control, top of joint use, lowest point of foundation excavation, hydraulic height, and the structure height. So first is exclusive flood control. So the reservoir capacity assigned for the sole purpose of regulating flood inflows to reduce flood damage downstream. In sometimes instances, the top of the exclusive flood control capacity is above the maximum control RWS elevation or either top of active conservation capacity or top of joint use capacity, whichever is greater. Next is the flood control pool. So reservoir capacity above active conservation capacity and joint use capacity that is reserved for flood runoff and then excavated as soon as possible to keep the reservoir volume in readiness for the next flood. Next is the joint use capacity. So the reservoir capacity assigned to flood control purposes during certain periods of the year. Normally when flooding is more likely to be a concern. So in this case, so if dako na jud ang flood, so let us pa na makapuan jud tong joint. So joint, so meaning murag magsama. And to conservation purposes during other periods of the year. Next is the active conservation capacity. So the reservoir capacity assigned is to regulate reservoir inflow for irrigation, power generation, municipal and industrial use, fish and wildlife, navigation, recreation, water quality, and other purposes. It does not include exclusive flood control or joint use capacity. It extends from the bottom or the lowest RWS associated with the bottom of exclusive flood control or the bottom of flood control pool or the bottom of joint use capacity to the top of the inactive capacity. So next is the inactive capacity. So the reservoir capacity exclusive of and above the dead capacity from which the stored water is normally not available because of operating agreements or physical restrictions, such as minimum hydraulic head needed to meet certain release requirements associated with power generation, irrigation, M&I, recreation, and environmental enhancements. So under abnormal conditions such as shortage of water or requirement for structural repairs, water may be evacuated from this space. The inactive capacity extends from the bottom of active conservation capacity to the top of dead storage. So next is the dead capacity. So the dead capacity is the reservoir capacity from which stored water cannot be evacuated by gravity using existing hydraulic structures. Next is the life capacity. So reservoir storage that includes exclusive flood control capacity plus joint use capacity plus active capacity plus inactive capacity. Next is the total capacity. Reservoir storage that includes the live capacity plus dead capacity. So meaning inactive, total capacity. Next is the crest of dam. So the elevation of the uppermost surface of a dam, usually a road or walkway, excluding any parapet wall, railing, crab, etc. on embankment dams. The crest of the dam is the top of the embankment, not including camber, crown, or roadway surfacing. So the extra height camber added to the crest of embankment dams is to ensure that the freeboard will not be diminished by foundation settlement or embankment consolidation. Next is the maximum water surface. So the maximum or highest RWS reached during the passing of flood event up to the PAMF. The maximum RWS reached during the passing of the IDF represents the maximum reservoir elevation used to size the dam and associated appurtenant structures such as spillways and outlet works. Top of exclusive flood control. So the RWS elevations at the top of the reservoir capacity allocated to exclusive use for the regulation of flood inflows to reduce damage downstreams. Top of joint use. So the RWS elevation at the top of the reservoir capacity allocated to joint use, flood control, and conservation purposes. Next is the lowest of foundation excavation. The lowest point of elevation below the stream that is reached during excavation of the dam foundation, excluding treated narrow and small fault zones. Hydraulic height. So the vertical distance between the lowest point in the stream at the axis of certain line of the dam or the invert of the lowest outlet works, whichever is lower, and the maximum controllable RWS, either top of active conservation or top of joint use capacity, which is higher of the two. Next is the structural height. So general definition is the vertical distance between the lowest point in the excavated foundation, excluding narrow treated smallest fault zones also, and the crest of the dam. So what is the functions of the spillways? So spillways are provided for storage, multi-purpose, and detention dams to release surplus water or flood water that cannot be contained in the allotted storage space. Any for diversion dams to bypass flows exceeding those turns redirected into the diversion system. Ordinarily, the excess storage is drawn from the top of the reservoir and conveyed through waterways or hydraulic structures such as spillways, outlet works, canals, pipelines, etc. back to the river or to the natural damage. So some of the spillways are used not only for floods, but it can use to be the bypass of the water, so going to the cities, to our homes, and to our offices. So that's the some functions of the spillways. Next, so in general, the importance of a safe, reliable spillway cannot be overemphasized. Many failures of dams have been caused by improperly designed and or constructed spillways or by spillways of insufficient discharge capacity. So in this scenario, so the government should get the best designers to fit the best designs to our cities or to the dams that can para musugapon siya sa ato ang cities para dili pud siya makuhanan og flood. Next, so the checklist. So checklist or the feasibility for making a spillways. So first is the data. A data table summarizes considerations that are necessary to prepare analysis and designs for modifying existing spillways and constructing new spillways. This list covers all levels of analysis and design, ranging from appraisals and feasibilities to the final designs. It is important to note that activities associated with the data table parallel and or are interactive with activities associated with the located table and the type and size table. Location, so for a location that summarize considerations that are necessary to properly locate a new spillway. So in this case, so dili po ka magpataka nga kuandra kanhi buhatan na to spillway. No, first is use the data, the dam, o ang causes o ang resolution. Next, type and size. So a type and size table summarize considerations that are necessary to properly select the type and size of modification to an existing spillway or a new spillway design. As with the data table and location table, the table covers all over the analysis and design. So types and size, so nakadepends pud na sa imong dam or mga river na butangan og spillways para mag-adto sa mga bypasses niya o sa iyang mga kung asa siya padulong. Dili pud ka magpataka kay kung dili nga na river nga ana is kailangan siya spillway pero dili ti ay. So dapat jud is necessary rin jud na mag-think jud kag taman. Next is the analysis and design. So an analysis and design table summarizes considerations needed to refine and or finalize the modification to an existing spillway or the design of a new spillway. As with the previous tables, this table covers all over the analysis and design ranging from appraisals and feasibilities to final designs. So this is the spillway profile. So as you can see, so first is the approach channel, reservoir water surface, inlet structure, control structure, conveyance feature, terminal structure, and exit channel. So first is musulod jud sa approach channel, reservoir water, so muna tong water surface, so inlet, so muna diay murag mga murag bangag or one or gate nga mag-control sa flood kung unsa lang ang mosulod. Control structure, so meron na kay machine diha, na machines na to control the gate to the excess floods or water. Next is the conveyance feature. So conveyance feature is the way padulong kung asa siya. Next is the terminal structure, or this is the storage of the water in case. And next is the exit channel. So that is the spillway profile. Next, so this is some examples of spillway. So as you can see, as I've said earlier, so reinforced concrete combined control structure, conveyance feature, and energy dissipation structure. So as you can see, reinforced concrete jud ang the best nga materials para sa atong dams spillways because siya ang nagapanog strength to cover to para masangga niya ang tubig nga mag-flow sa iyaha. Next is this is the riprap terminal structure, riprap field trench to limit erosional head cutting. So the flow of water, riprap approach channel, reinforced concrete grade, control steel, riprap exit channel. So this kind of spillway or channel, mo ni sila ang pwede na tumabutang sa emergency spillway. Next is the reinforcement concrete terminal structure, reinforced concrete conveyance feature. Mura ni siya og katong step service spillway. So integral with concrete dam, Santa Cruz Dam, New Mexico Stream Commissions, New Mexico. So mura siya og stairs but nagapuan ni siya reinforcement concrete gyapon and taas ang iyang height because para maka-prevent kuan ang flood. So ang naputay mga example ani makita pero dili siya murag step pero kanang nakakaron sa bangkiruhan sa ubos sa bridge. Ginabutangan nila yun ana kay para in case of flow dili dahil mo diretso sa mga balay mang-control niya ang mga water. Next is this is the Morning Glory Spillway. So Morning Glory Spillway, so in case if the water will go higher, magkuha na siya og mga volume, higher volume. So mag free fall lang ang nasi bangag, so mag free fall ang water, mo to ang murag mo suyop or mo siphon sa water, not siphon but basically pwede pod nga ang water mo diretso dito sa inlet abot sa outlet, depende kung asa naka-indicate ang bypass sa iyahang pipe para magbabas og water sa dam. So ever mag-ulan, magkusog ang ulan, heavy rain, thunder nga mga storms, so magpa-causes na siya heavy rainfall, so makontrol niya necessarily dili na kailangan og control nga kailangan nimo bantayan pa but pwede na nimo na siya mapuanan. Pero ang advantages sa mga spillways is good siya para sa mga dams but ang disadvantages is dagko siya og mga cost kailangan nato og kuan. So mao ang government ang halos nagapuan jud sa puanan ning mga structures of designs. So that's all. Thank you.